Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss one of the partitioning method that is used for clustering, that is k-means. So in this we will be going to cover mainly the basic concepts of k-means, and we will also see the procedure of how the k-means algorithm could be applied, and we'll see the numerical example, very simple example to understand how the k-means can be applied to segment the data into the different clusters, and we will also discuss the different issues with the k-means cluster. The simplest and most fundamental version of cluster analysis is a partitioning, which organizes the objects of a set into the several exclusive groups or the clusters. That means each cluster is going to have only one object. To keep the problem specification concise, we can assume that the number of clusters is given as a background knowledge. So this parameter is the starting point for partitioning methods. So formally, a given data set D of n objects and k the number of clusters to form, a partitioning algorithm organizes the objects into the k partitions, where k is less than or equal to n. That is, each partition represents a cluster. So the clusters are formed to optimize objective partitioning criteria. What is the objective partitioning criteria? As I said, it is very important. That is dissimilarity function based on distance, so that the objects within a cluster are similar to one another and dissimilar to objects in the other cluster in terms of the data set attributes. So that is a very important one. So we have to optimize this objective function or the partitioning criteria. You have to partition the objects. So in order to optimize this, what need to be optimized? The distance, that is, objects within a cluster are similar, and the objects in the other clusters are dissimilar. Suppose a data set D contains n objects in Euclidean space. Partitioning methods distribute the objects D into the k clusters. Let us say C1, C2 and so on. C, k are the k number of clusters. So that is, each cluster Ci belongs to D, and the Ci intersection Cj equal to 5. There is no common similarity. So that would be expressed as Ci intersection Cj. That means no two clusters are having the common data objects. That is for the I value more than or equal to 1 and the j is less than or equal to k. So an objective function is used to assess the partitioning quality, that objects within a cluster are similar to one another but dissimilar to objects in the another clusters. So the objective function aims for high intra-cluster similarity and low inter-cluster similarity. So the distance between the objects within the cluster and the distance between the objects outside the cluster. So here the high intra-cluster similarity, this should be high, and suppose if you take any data point from these two clusters, and this inter-cluster similarity should be low. A centroid based partitioning techniques uses the centroid of a cluster Ci to represent that cluster. Conceptually, the centroid of a cluster is its center point. The centroid can be defined in various ways, such as by mean or a median of objects or points assigned to the cluster. So the difference between the objects, that is, I think this is This is PICI. The representative of the cluster is measured by the distance, that is Pi and Ci, where the distance of xy is the Euclidean distance between the 2 points x and y. As we already discussed in the previous lecture, the quality of a cluster Ci can be measured by within the cluster variation, which is the sum of squared error between all objects in the Ci and the centroid Ci, defined as E. This is a error, the squared error. So here the E is the sum of the squared error for all objects in the data set, and P is the point in a space representing a given object, and Ci is the centroid of a cluster Ci. Both P and Ci are the multidimensional. So this objective function mainly tries to make the resulting K clusters as compact as separate as possible. Optimizing the within the cluster variation is computationally challenging. So in the worst case, we would have to enumerate the number of possible partitionings so that are exponential to the number of clusters, and check the within the cluster variation values also. And it has been shown that the problem is a NP hard in general, that is a Euclidean space even for the two clusters, that is even for the K is equal to 2 also. Moreover, the problem is a NP hard for a general number of clusters, the K even in the two-dimensional Euclidean space. If the number of clusters K and the dimensionality of the space D are fixed, the problem can be solved in order of n to the power of dk plus 1 log n, where n is the number of objects. So to overcome the prohibitive computational cost for exact solution, greedy approaches often used in practice. So a prime example is a k-means algorithm, which is simple and commonly used. So here the k-means algorithm defines the centroid of a cluster as a mean value of the points within the cluster. Then the rest of the procedure will be followed as the first, it randomly selects the K of the objects in the D, each of which initially represents a cluster mean or a center. For each of the remaining objects, an object is assigned to the cluster to which it is the most similar based on the Euclidean distance between the objects and the cluster mean. The k-means algorithm is then iteratively improves the within the cluster variation. For each cluster, it computes the new mean using the objects assigned to the cluster in the previous iteration. All the objects are then assigned using the updated means as the new cluster centers. The iteration, this process continues until the assignment is stable. That is, the clusters formed in the cluster round are the same as those formed in the previous round. So that is the way let us just quickly check the procedure, the algorithm for this k-means. So here the algorithm for partitioning, where each cluster center is represented by the mean value of the objects in the cluster. So here the input parameters are the number of clusters, and D, that is a data set containing n objects. It is going to give output as a set of K clusters. How the methods would look like? The first, arbitrarily choose the K objects from the D as initial centers and reassign each object to the cluster to which the object is the most similar based on the mean value of the objects in the cluster. Update the cluster means, that is, calculate the mean value of the object for each cluster, and then this process would be repeated until there is no further change. So let us quickly walk through one simple example. I'm not going to calculate I'm not going to solve this entire problem. I will give us a brief idea how the k-means algorithm would be applied to solve or to cluster these data points into a specified number of clusters. So cluster the following 8 points with xy here representing locations into the 3 clusters. Let us say A1, A4 and A7. These are the this entire data. We have 8 data points. Each 8 data point would be represented in the form of X and Y, that is represent the locations. So now we have to group these data points into the 3 clusters. Group these data points into 3 clusters. So as per this k-means algorithm, first initially we have to randomly select the cluster centers. So in this case we would select A1, that is 210. Next let us take A4, that is 5, 8, and then A7 1, 2. So these are the 3 data points would be selected as the cluster centers initially. So now what need to be done here? So we have to calculate the distance, because there are 8 data points in this. We have to calculate the distance from the each center, how far the each data point is from each cluster. So this is the calculated values, distance is calculated, and you can easily understand how a particular value would be calculated. I would also explain here. Like suppose if you want to find out the distance, as I said there are 8 data points. So these are the 8 data points. We have to find out there are 3 clusters. This is cluster 1, 2, 3. Okay, because we have to group these data points into the 3 clusters. Now we initially pick the 3 clusters, that is A1, A4, A7, I think it's so. So now we have to find out the distance from each cluster to the data point. So like suppose A1, that is because the cluster head is also same. Obviously there is no, because it's the distance is 0. So that is in this example, the distance method that is used to calculate is x1 minus y1 plus x2 minus y2. x2 minus y2. So for example, if you take the 2 data points, that is, let us take this one. That means the cluster head is A58, that is A4 and A1. The data point A1, that is 210. So x1, y1, x2, y2. So now, and if you plug these values into this equation, then you have 5 minus 2 plus 8 minus 10. So how much it is? It is 3 plus 2 equal to 5. So similarly, it is very simple function, that is distance function. You can also use a Euclidean distance also to calculate the distance between the 2 points. So like this, we can calculate the distance from the each center, the cluster head, to the respective data points. So like this is the first iteration we calculated. So then next, what need to be done? So we have to update the center. How we can update the center? So now let us see. So here C1, this is only C1, only one data points very belongs to the cluster 1. So then its mean value will remains same. Okay, that's mean value. So then that will be again the same cluster head. Next, if you look at another like C2, 1, 2, 3, 4, 5 data points. So then we have to find out the mean value of this 5 data points. Mean value of all these 5 data points. So then again for the C3 also, third cluster, for the third cluster like C3, and there are 2 data points. Okay, initially, right? This is the first initial assignment, 3 clusters. Okay, I would write, let us take, okay, so first C1 has only one data point, and then C2 another cluster, and C3. So C3 has 2 data points and C2 has 4 data points, 4 data points, 5 data points. How many? 1, 2, 3, 4, 5 data points. So it has gone. Okay, so C3 has 2 data points, C2 has 5 data points, and C1 has only 1 data point. So then we'll calculate the average of, like suppose if you take all the data points belongs to the cluster C2, or if you take the C3, what are the data points? A2 is 1 data point and A7 is another data point. We'll calculate the average, the mean of based on these 2 data points, and that value will be a center of that cluster C1, C3. So then, like suppose in this case A2, that is 2, 5, I think it's not visible. For example, here C3, there are 2 data points, right? 2 data points assigned initially. So A2, 2, 5, and another data point is A7, that is 1, 2. Like suppose these are the data points in this any particular cluster. Then we calculate the average. Like here, the 3 means 1.5 and 7 means 3.5. This will be a centroid of this particular cluster. Then we again will calculate the distance. Similarly for the C2 also. C2 there are 5 data points. We'll find out the mean, and then that will be considered as a new centroid. Again we'll calculate, so that means we'll update the centers, and then we calculate the distance from each data point to that particular cluster head. Then again assign, because how we are going to assign, though I said many times. Like for example, here you can see the A2 data point. A2, it is a, let us take this values in terms of units, like a kilometers, just for understanding, not right. So this 5 kilometers away from, that is the distance to the center one, the cluster 1 is 5 kilometers, and 6 kilometers away from this center 2, that is next cluster, and 4 kilometers. So it is very close to the third cluster. So that's why this data point been assigned as belongs to the cluster C3. Similarly, the rest of all the data points would be assigned, and then once we do this clustering, and we'll find out the center, that is by taking the average of the data points, and then again we'll calculate the distances like this, and again we'll reassign the data points. So this process would be repeated until there is no further reassignments. Like suppose the previous assignment, the data points, previous assignments, let us say there are 2 clusters, the previous assignment and the present assignment the same, right? Then there is no change in the compared to the previous assignment. Then we will stop the clustering, and those clusters would be the best. So let us see what are the other issues with the k-means clustering. The k-means method mainly is not guaranteed to converge to the global optimum, or often terminates a local optimum. The results may depend on the initial random selection of cluster centers. To obtain the good results in practice, it is common to run the k-means algorithm multiple times with the different initial cluster centers. For example, if you look at the time complexity of this k-means clustering algorithm, that is order of nkt, where n is the total number of objects, k is the number of clusters, and t is the number of iterations. Therefore, the method is relatively scalable and efficient in processing the large data sets. There are many other versions of the k-means methods. So these can differ in the selection of initial k-means and the calculation of dissimilarity and the strategies for calculating the cluster means. So based on these three, there are variety of k-means methods were proposed. The k-means method can be applied only when the mean of a set of objects is defined. So this may not be the case in some applications, such as the data with the nominal attributes are involved. The k-modes method is another version of k-means, so which extends the k-means algorithm to cluster the nominal data by replacing the mean of clusters with the modes. That is a repetition, number of times that is repeated, a particular value is repeated. It uses the new dissimilarity measure to deal with the nominal attributes and the frequency based method to update the modes of clusters. So the k-means and the k-medots methods can be integrated to cluster the data with the mixed numeric and the nominal values. So let us see what are the other issues also, mainly that is the necessity for our users to specify the k, that is the number of clusters, in advance. That is a disadvantage because it is not easy task to specify the number of clusters initially. So there are many other studies were implemented to overcome this difficulty. However, such as by providing an approximate range of k values and then using analytical techniques to determine the best k by comparing the cluster results obtained from the different k values. The k-means method is not suitable mainly for discovering clusters with non-convex shapes or clusters of very different size. Moreover, it is sensitive to the noise and outlier data points because the cluster center would be calculated based on the mean value. So if there is outlier, like let us take the data, the mean value, okay, like suppose this would be, if it is considered as a normal distribution, the mean value, or if you take any data, the data points, and if you calculate the mean value, and if there is a like suppose let us take the class 60 students weight. So let us say average weight is some 48 kgs. 48 kgs is average weight of 60 students in a class. So in this case, suppose if there is, let us imagine there is an outlier present in this data set. So like suppose 200 kgs. So it would influence the average weight. Okay, so that's why it is sensitive to the noise and outlier data points. So use a good sized set of samples in clustering. Another is to employ a filtering approach. One is a good sized set of samples in clustering. Another is we can filter, that uses a spatial hierarchical data indexes to save the cost when computing the means. A third approach explores the micro clustering idea, which first groups nearby objects into the micro clusters and then perform the k-means clustering on these micro clusters. That's it.